go. So this is the end of unit review for chapter 18. Question number 1, it says work out the gradient of each line on the graph. So every single line that's on the graph, we need to work out the gradient. So the gradient is fairly simple. So if we look at number 1, we can just say that, oh, gradient of a line. There are two ways you want to find it. You can use your y2 minus y1, x2 minus x1, or you can use this simple one. Gradient is equals to change in the y over change in x. Y coordinate and x coordinate. Generally, this will lead to my formula y2 minus y1 over x2 minus x1. Means the second coordinate the y value and then minus the first coordinate's value. And we do the same thing for the x coordinate. So the change in y will be at the top, will be the numerator. Change in x will be the denominator. So let's just pick, look at this one here, A. Look at this line right here. The first thing that you need to do is you need to pick 2 points. Points that you need to pick normally should be in the cross section here. So this one is a bad point, no go. All these are bad points. You can look at the points that I pick here. This is a good one because it tells me clearly where the location of the point is. It's on the y is 4 or x is -3. So it positions very well. And then I'd like to find another one. Possibly, oh, here, this is a good one. Let's pick this one. Okay, it's not to say that you can't pick the rest, but these are the easier ones. So always go up or down first, or you want to go right because you can, doesn't really matter. You can go right first. Always must go right, there's no going left. Okay, so you go right 3 and then down. This is going downwards, down 1. So it means that the y coordinate changed by 1, while the x coordinate changed by 3. So the first gradient I can write, gradient for A, is -1 over 3. Plus the change in y is going down by 1. This one is right. Must always go to the right. You cannot say go left. Always go to the right. So left and right will be my x, but in this particular case, it only goes to the right. And then the top will determine whether it's a positive or a negative. Going upwards is a positive, going downwards is a negative. Again, let's go to B. Okay, look at B is a little bit tricky because it's a very, very long and steep line. So I will pick 2 points. Here will be 1. Just put down the color so you can see. Here will be another one. Okay. So go right first. Right, go by 1. And we're going upwards. 1, 2, 3, 4, 5, 6, 7. 7 up. Okay. So that's how you want to calculate this amount. So we can just write it. Change in y is 7. And then change in x would be 1. So gradient can be 7. Now, let's look at C. Line C. Line C is here. Just going to put 2 points. This is a good point. And, well, this is good as well. This is good as well. This is good as well. Up to you which one you want. Doesn't really matter. I will pick the closest because it's the easiest. Go right first. Right 2. Up 1. Right 2. Up 1. Oh, that's it. Right. Okay, now let's erase all of this and look at question number 2. Oh, don't want to erase the formula though, because we need to find the gradient. So now, for number 2, a gradient of a straight line between 0, 0 and 10, 2. Yeah. So we're going to find change in y over change in x. You can pick which one, but normally I would pick the one with the larger value for y and put it on the top. Okay, so I'll take this minus this and this minus this. It's easier that way because this one is bigger. If you don't want, you feel uncomfortable doing it, you can straight away take this coordinate and just write like that. The first coordinate, y on top, y at the bottom, x at the bottom. Then you just draw your minus, minus. Do the same thing, y on top, x at the bottom. Then you get -2 over -10, which is a little bit tricky. Then you're going to get 1 over 5. That's it. That's all you need to do. Then let's look at B. Do the same if you want to. Put the 0, put the 6 first, y coordinate, x coordinate, minus, minus. And now we're going to do this one here, -6. Trust the process. Negative, negative, this one will eventually make a positive. So 6 plus 6 over -6, 12 over -6, -2. Yeah, that's how you get it. Look at C, we can do the same again. Y, x. 2, oh. And then the other one, minus, minus, -2, negative. Trust the process. Do the same thing because you know if it is a negative and a minus together, it will make a positive. Do it. 2 plus 2 is 4. 5 plus 3 is 8. Slow and steady. Now, done already? We go to number 3. Find the gradients of the line of this equation. So let's look at number 3. Equation of a line. Y is equals to mx plus c. M will be the gradient because we're only looking for the gradient. Whatever's beside your x when y is positive. Y is positive, clear. Positive and, well, 1. Gradient for the first one, 3a, gradient would be, just write. Instead of writing the word gradient, you can just write m is equals to 4. Look at B. Is y 1 and positive? Yes, it is. Then it will be -5. C. Now, although y is on the other side, it is still 1 and positive, and x is still on the other side. We can just take it. So when gradient is a 3. And last one is a little bit difficult because y is with x on one side. Cannot. Y must be alone on one side. So I'm just gonna bring it out for a while. I'm just going to take this x and bring it to the other side. So I'm going to leave y alone. There we go. So you get a negative something, which definitely, if you know, is one that is an invisible one. So your answer for the gradient will be -1. That's it. Number 3. Now, let's go on and look at number 4. Write each formula in the form of y equals to mx plus c. Means we need to just rearrange them by making y the subject. You have to do this slowly, because if you don't, you will make mistakes. So let's look at the first one here. 2x plus y is equals to 4. So here you go through the magical bridge of the equal sign. It will become negative. Well, don't leave it like that. Just put it in front and give it a practice so that it is exactly how the examiner wants it to be. Get B. X plus 4y equals to 2. Then you feel like, oh, now I need to do 2 steps. Not a problem. Move everything first before doing anything to your y. 4y is equal to 2 minus x. Now, if I want to remove that 4, I need to divide 4 for every term. So I get y is equal to 2 over 4, it doesn't really matter, minus x over 4. Just rewrite again. 2 over 4 can simplify to 1 over 2. Now look at question C. Two y plus 4 is equal to x. Move the 4 instead, because we need to leave y alone. Everything divided by 2. X over 2 minus 2. Okay. Go to D. 3. X minus y is equals to 2. Okay, there are 2 ways you can go about, but try your best not to expand the equation. It means that I'm going to take this 3, since it's a multiplication here, I'm just going to bring it over and make it into a division. I'm going to divide by 3 here, divided by 3 here. Don't be frightened by the fraction, it's okay. So now, I'm going to move my y first. If you're not really good at moving multiple terms, just do it one at a time. Move my y to the other side. X is equals to 2 over 3 plus 1. Now, I need to leave my y alone, so I just will move this to the other side. Try to put it beside on the right-hand side here. It's easier to see. This is going to be x minus 2 over 3 is equals to y. And it doesn't look really good. Rearrange, put your y on the left, just flip the whole equation to the other side. Nothing has changed or look the same. Okay, that's for number 4. Check out number 5. Number 5 says that these are equations of a straight line. Find the gradient of each one. So in order to find gradient, we need to leave y alone as always. 2x plus y is equals to 9. Move the x to the other side. What's a 2x per se? Y is equals to negative 2x plus 9. By now, you should be able to do it this way, and you should be able to get your gradient, which is the number beside x, or the coefficient of x, which is negative 2. So get B. X is equals to 2y plus 4. Not really good, or don't really like it. Well, I would flip the whole equation first. 2y plus 4 is equals to x. Looks better now, isn't it? X minus 4, y, all divided by 2, divided by 2, divided by 2, x over 2 minus 2. So since this one looks a little bit different, it is actually y is equal to half x. It's the same. X over 2 and half x, they are the same. So your gradient would be 1 over 2. They're the same thing. When you multiply by half, or you divide it by 2, it's the same thing. Done. Let's look at the last one. Looks a little bit tricky, but it is not. It's actually far easier than the rest. In order to remove the fraction, I may have to multiply everything by 4. So that I can remove the fraction. Then it's done. Y is equal to, well, 4 multiplied by half, you get 2x. 12 multiplied by 4, you get 48. So your gradient would be 2. And that's it. Now let's look at number 6. It says here, these are equations of 5 straight lines, and then we need to find lines that are parallel. What makes them parallel is when they have the same gradient. If they have the same gradient, they are parallel. Okay, so let's just write down all the equation and see if we can do anything with it. Doesn't look really good here, so I'm just going to rearrange it to look like this. Let's go for B. C. 2 divided by 2 divided by 2. D. Divided by 2 divided by 2 divided by 2. And that's going to be E. Move the Y to the other side. Move the 1 to the other side. Flip the whole thing. Now, compare the gradients. -2, 2, -2, -1, 2. So those that are the same would be A and C, B and E. D is not parallel to anything. Nothing. This is your answer. Now let's go to 7 and 8. Use the graph to find the solution to each pair of simultaneous equation. Now, might be a little bit tricky, but it's not that difficult. So you can see here, just try to use or try to make the y the coefficient of 1. So you just look at the first one here. X plus 2y is equal to 5. 2y is equal to -x plus 5. Y is equal to all divided by 2, -x over 2 plus 2.5. 3x plus y is equals to 13. Y is equals to -3x plus 13. So you can see, instead of looking at the gradient, look at the y-intercept. 2.5 will make this line. 13 will make, was not there. So let's just try to see what is the other line here. Negative gradient, can you see? Good call. So where do they intersect? You can actually see it. Right in the middle right here, you can see tick and find your x value. 4.2. Right, so since we have that already, these are all the green lines. These are all the red lines. Red lines, red lines, green lines, red lines. Now we're missing the other line. Let's just label it as a blue line. Must be the other one. So blue and green, find your x value. 6.4. Next one is the blue and the red one. Blue and red. And 5.6. But if you get your answer a little bit off, it's okay, acceptable still. Right? Now look at 8A. Draw graphs on straight line with this equation. Draw both lines in the same grid. Use your graph to find approximate value of this solution or this simultaneous equation. So it's actually quite easy because we're just going to write it down first, where we need to, well, at least get certain values out. So y is equals to 3x plus 7. This is one of the lines. So when x is equals to 0, I need to find out what's the other coordinate. Y is equals to 3 times 0 plus 7. The y coordinate will be 7. So here I get one coordinate. I need to find two coordinates, by the way. So I need to find the other coordinate. I will say, oh, what if x is equals to 1? Y is equals to 3 times 1 plus 7. Y is equals to 10. My coordinate will be 1, 10. So I need to draw a graph that looks like this. And then for the other line, I need to do the same. 2y plus x is equals to 2. If you are not really comfortable, we can rearrange it. So rearrange is better. So 2y is equals to negative x plus 2. Y is equals to negative x over 2 plus 1. I would suggest you put x is equals to 0 first. And then the other one must be a multiple of 2. So the coordinate you get was 0, 1. The other one, I would suggest do not put x equals to 1 because that'll make your life a little bit difficult. So x is equals to 2, multiples of 2. Depending on the denominator here, if it's 3, then multiples of 3. Y is equals to negative 2 over 2 plus 1. Y is equals to negative 1 plus 1. Y equals to 0, 2, 0. There we go. We've got two coordinates for each line, and then we should just be able to just draw the line and then be good to go. Let's move this downwards. So that I can draw a line for this. Do you know whether it's enough or not? Hopefully it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 9, 8, 7, 6, 5, 4, 3, 2. Oh, shoot. Just gonna move it all up. Four, 1, 0. So I need to extend the graph a little bit. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's draw this graph. Let's just label this as a green graph, okay? This is my green graph. 0, 7, 1, 10. Okay, so this is my line. And then the other one is 0, 1, 2, 0. Okay, it seems to me that they are meeting on the other side of the graph. So I need to extend this line here. -1, -2, -3, -4. So this is where they meet. And I need to find the value for this one. Could be just x equals to -1. That is the solution. Number 9, the cost of hiring a car is 40 plus a charge of $30 per day. So they gave you a fixed amount that will happen every single day. And the initial starting price, it means that this is a must to pay, regardless how many days you use it. So Let's look at the formula that we can create here. But they ask you to calculate first. How much will it cost to hire a car for 2 days? So it's always 40 plus $30 times 2, because 2 days. So you can already see a formula here, whereby it's 40 plus 60 is equals to 800. If we just replace the number of days with an unknown called V, then you can get your answer already for question. Find a formula to show the cost is equals to 40 plus 30 multiplied by the number of days. So if it's multiplication, you can just put right at the side. That's the formula. Draw a graph to show the cost of hiring a car. Okay, since we need to draw a graph, we need 2 coordinates. We already have one from the beginning, from the first one. 2 days is equals to $100. Right? Then let's see if you have 0 days. So the other coordinate would be, let's just put 0 then. So let's say if it's 0 days. So it will be cost equals to 40 plus 30 times 0. So it will be $40. So that's how you can find the second coordinate. So it will be 0 days, $40. Now we just need to draw a graph for it. Yeah, I think it's easier that way. Let's just draw a graph. My coordinates away. Right, so this one will be 0, it's the number of days. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's put at 50. So 0 days is 40, so that's a little bit tricky to draw, but yeah, you can get it. 2 is 100. Let's see if there's anyone that I can get. So, what was it? This is how the graph will look like. And then it says a driver pays 220 to hire a car. Use the graph to find the number of days she had as the car. 220 should be about here. This is a rough estimate though. Yeah, if my graph were to be correct, it should be about, I think, 5 days. Yeah, 5 days will do. Okay. Now let's look at number 10. The exchange rate between Hong Kong dollar, HK dollar, and Pakistani rupees PR is HK1 is equals to 12.2 PR. Draw graphs to show the exchange rate. Put HK as a horizontal axis, go up to 100 HK dollars. Use the graph to convert 500 PRs. Wow. So 100 Hong Kong dollars would be 1,220. Let's just put, I think we should be able to do this. We might need a bigger space. We just find more space. Okay, so I'm just going to move this up. We might need more than 12 though. Let's start from the top here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think that's better. Yeah, definitely need 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Extra a little bit so that I can draw an arrow. 0. So this will be Hong Kong dollar. This should be Pakistani rupees. So we have 100, is it? Up to 100 Hong Kong dollars. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So at this particular point, right, you can actually see that it is a direct proportional plot. It means that it will start from 0. 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1001, 1002, 1003. So 0, 0 would definitely be a point because with 0 Hong Kong dollar, you get 0 Pakistani rupees for sure. Now we just need to, well, find another number that is suitable. So go up to 100 Hong Kong dollars should be 1,002. So 100 Hong Kong dollars should be 1,220. So it should be about here. And then it says use a graph to convert 500 Pakistani rupees into Hong Kong dollar. So let's try to do it. 500. Let's say perhaps it's like 410-ish. Plus or minus, I think 410. Okay, 41, sorry. 41 Hong Kong dollar. Get a calculation to get more accurate answer to part B. So it means that I need to use a formula. Well, if I don't want to use a formula, I can actually just use this one here. 500 Pakistani rupees, so 1 Hong Kong dollar equals to 12.2 Pakistani rupees. So now I don't know how many Hong Kong dollars I have, but I have 500 Pakistani rupees. So here I just need to figure out 12.2 times 1 is equals to 500. I just take my calculator, take 500 divided by 12.2. I get 40.98. So I do the same on this side because mathematics is just like that. So Hong Kong dollars will be 40.98 is equals to 500 Pakistani rupees. The answer is 40.9. And that's about it.